Okay, so good morning to all of you. Look at here. I am going to deliver my first lecture today, which is based on set theory. The topic is set theory. So basically, what is set theory? What is set? So we all know a set is a collection of well-defined different objects or distinct objects. So what is set? Set is a collection of a collection of collection of well-defined distinct object. Is set. For example, name of the rivers, name of the mountains, etc. So that is known as set. Set is a collection of well-defined, different or distinct object. Now, the objects in the set are called the elements or the member of the set. The objects in the set, the objects in the set is known as member or elements of the set. The object in the set is known as member or the elements of the set. So usually we denote set by capital letters and the objects or the members of the set by small letters. So usually, just wait. So usually we denote set by capital letters and the member of its set and the member or the elements of set. No, that doesn't require. So usually we denote set by capital letters. For example, set of vowel letters. V is a set of vowels. So that is a set of vowel letters. Similarly, if we are going to describe the word probability, look at here the word probability, set of vowels of the word probability. So look at here. If I denote this by A, so what are the vowels in the word probability? They are O, A, I. So O, A, I. O, A, I. We can't write here there in this word probability there are two I, but we can't write the both two I's. We have to write only one. So that's why I have said earlier, set is a collection of well-defined different object or distinct object. We have not write the both and the both word I. We are the both letter I. We are only writing the one letter I. And one more thing, in the set order doesn't matter. In a set, order doesn't matter. In set, order doesn't matter. Okay, so we can write O, A, I, or we can write A equal to A, I, O also. Just because of the set here order doesn't matter, so we can write A by O, A, I, or A equal to A, I, O. Is that clear? Okay. Now, the thing is how we represent a set, representation of set. Okay, so a set can be represented just a minute. So a set can be represented by two methods or two methods. The first one is roster method or tabular method. And the second one is set builder form or set builder method. Okay, now come to the first one. There are two methods from which we can represent a set. The first one is roster method or tabular method, and the second one is set builder method. Set builder method. Now, what is roster method and set builder method? So the first one, roster method. So in this method, we represent the elements of a set in a bracket, in a middle bracket, and in between them commas. We separate the elements of the set by commas, and we are going to represent them in between a bracket, which is second bracket, or you can say middle bracket. So for example, in this representation, in this method, we represent the set the elements in a set of a set in a bracket which is this one, sorry, in a bracket, no, so in this method we represent the elements of a set in a bracket where each elements will be separated by a comma. For example, A is a set of natural number from 1 to 100. So this is a set, and here we represent the elements of the set by roster method. And now the second one, that is set builder form. How we represent a set by set builder form or set builder method. Second one. So in set builder method, we are going to represent the elements of a set. How we are going to represent it? We are going to describe it by their nature, by their property. We are going to describe the elements by the property. We are going to describe the elements by property. A property that is must satisfied by its element. Say, describe. In set builder method, set is described by a property which its elements must satisfy. Must satisfy. Sorry. So look at here. In set builder method, set is described by a property which its elements must satisfy. For example, is a natural number less than 10. So look at here. Here x such that x is a natural number less than 10. That means the elements of this set, that is less than 10, the elements of this set will be less than 10, and they are natural numbers. So we can say that is from 1 to 10, sorry, 1 to 9, not 10. So in this way we can also describe some other definition or other examples such that x such that x such that x is an even number x such that x is an even number divisible by divisible by 4 and less than 100. So look at here. In the second example, x is an even number divisible by 4 and less than 100. So we are going to say the elements of these sets are those numbers which are even, which are divisible by 4 and they are less than 100. So this property must satisfy by the elements or the member of that set, of that particular set. So in this two way we can represent a set, either by roster method or tabular method or by set builder method. Now the next one, how the types of set. Now next one is the types of set. First one, there are different types of sets. Now we are describing it one by one. So the first one is empty set. So what is empty set? You can say a set which has no any element. That is known as empty set. A set which has no element. A set which has no element at all. A set which has no element at all is known as empty set. So what is an empty set? A set which has no any element is known as empty set. It is also known as phi. For example, this one is an empty set, or we can say this one is an empty set. So an empty set is what type of set? A set which has no element at all is known as an empty set. Okay, phi is the symbol of empty, so phi is an empty set, and this set where no element is there. The second one is singleton set. Now, what is singleton set? A set which has only one element. A set which represents by only one element, that is known as singleton set. A set which has only one element is known as singleton set. A set which has only one element is known as singleton set. For example, a set which has only element that is 0 or any alphabets like A. So this type of set which has only one element, that is known as a singleton set. So these are the two examples. So the two types of set. The first one is empty set. It is also known as null set or void set. It is also known as null or void set. Null or void set. And the second one is singleton set. Okay. Now the next one. The next one is finite and infinite set. What is finite and infinite set? Finite sets. So, what is finite set? A set is known to be finite, or we can say a set is to be finite if the elements of the set is countable and the counting process has an end. A set is known to be finite. A set is known to be finite if the elements of the set are countable and the counting process has an end, and the counting process has an end. Or we can say a set is said to be finite if the elements of the sets are countable and there is an ending of that count. Okay? Now, for an example, a set of natural numbers from 1 to 1000. A set of natural number x such that x is a natural number up to 1000. So these type of sets are known as countable set, or we can say finite set. Similarly, we can say the English alphabets, the set of English alphabet. Wait. So these types of set are known to be finite set, or we can say they are countable sets. Now come to the process, what is infinite set. Okay. What are infinite sets? We can say set is known as infinite set, in which the element or the member of the set are infinite, which we can't count. A set is known to be infinite whose members are countless. Whose members are countless. Whose elements or members are countless. We can say a set is called infinite set, in which members we can't count. The sets members we can't count, that is known as infinite set. For example, set of natural numbers. Set of natural numbers. The set of name of the males in this world. So these are uncountable. These elements are uncountable. So that is known as infinite set. So that's why it is known as infinite set. Now the thing is, what is finite set, infinite set we already done. Now what is the size of a set? It is also known as cardinal number. The size of a set, which is known as cardinal number. So what is cardinal number, or what is size of a set? So size of a set, we can say the cardinal number is the element of the set. That means how many elements be in the set, that is known as the cardinality of the set, or the size of a set. Okay, so what is size of a set or cardinality of a set? Wait. Elements of a set, the number of elements of a set is known as the number of elements of a set is known as the cardinal number of the set. Cardinal of that set, cardinal number or cardinality of that set. Cardinality of that set, or we can say the cardinal number of that set, or the size of that set. For example, a set of 1, 2, 3, 4, 5. So here the cardinality of the set is 5. Here there are 5 elements, so the cardinality of the above set is 5. Just because of there are 5 elements in this set, so the cardinality of that set is 5, or we can say the size of that set is 5, or the size of that set is 5, or the size of the set is 5, because here are 5 elements. Because in this set there are 5 elements. In the set there are 5 elements. In the set there are 5 elements. Okay, thank you.